Welcome to qnawire.
Hello students, so the first part of the question is to calculate the weight by volume percentage concentration of acetaminophenone. So we have been given that 160 mg of acetaminophen is in 5 ml of solution. So here to calculate the weight by volume percentage, we'll be using this formula which is equal to the weight of solute in gram divide by the volume of the solution in ml multiply by 100. So let's put the value. So here the weight by volume percentage is equal to, since it is 160 mg, so in gram it will be 0.160 gram divide by 5 ml into 100. So here it is equal to, so here the weight by volume percent concentration is 3.2%. Now let's move towards the B part of the question. So here in B we need to calculate the amount of acetaminophen contained in a bottle that holds the 4.0 FLOZ of bottle. So here, since 1 FLOZ is equivalent to, this is OZ is equal to 29.5735 ml. So we have been given that, so here the 4 FLOZ is equal to 4 into 29.5735 ml, which is equal to 118.294 ml. So now we'll calculate the amount in grams of the acetaminophen. So here it is equal to the weight by volume percent concentration multiplied by the volume of solution in ml. So let's put the value. So as we have calculated the weight by volume percent, which is 3.2%, multiplied by the volume of the solution, which is 118.294 ml. So here it is equal to 0.3785 gram. So this is the amount of acetaminophen present in the volume of 118.294 ml. Now the second part of the A is to calculate the weight by volume percentage concentration of the lithium chloride. So here we'll be using the same formula. So here the weight by volume percent is equal to the amount of lithium chloride, which is 10 gram, divided by the volume in ml, which is 750 ml of the solution, multiplied by 100. So here it is equal to 1.33%. Now let's move towards the B part of the question. So the B part of the question is to calculate the weight by volume concentration of NaNO3. So we will be using the same formula. The weight by volume percentage is equal to the weight which is given of the NaNO3, which is 25 gram, divided by the volume in ml, which is 150 ml, multiply by 100. So by calculating it, we'll get the weight by volume percentage, and it is equal to 16.67%. Now the C part of the question is to calculate the weight by volume concentration percentage of concentration, which is equal to same. We'll apply the same formula as in the first question. So here it is equal to the amount of NaOH, which is 40 gram, divided by the volume of NaOH in the solution, which is 1.50 liter. So we need to convert it into ml. So we'll multiply by 1000 and this whole multiply by 100. So here it is equal to, so by calculating it, since here the volume is 400 ml, so it is equal to 10%. Now let's move towards the third question, A part. So here the question is to calculate the concentration of KCl. So we'll be using this formula where the molarity, which is denoted by capital M, is equal to the moles of the solution, which is denoted by N, small n, divided by the volume in liters. So let's put the value over here. So here the molarity is equal to number of moles, which is 3.5 mole of the KCl, divided by the volume, which is 1.50 liter. So it is equal to, so by calculating we'll get 2.33 molar. Now let's move towards the B part of the question. So here we need to calculate the concentration of the NaNO3 similarly. So let's put the value. So here the molarity is equal to the number of moles, which is 0.44 mole, divide by the concentration, divide by the solution volume, which is 0.855 liter. So by calculating it, we'll get the concentration of the NaNO3, which is 0.52 molar. Now, so this is the answer. I hope you find this video helpful. Thank you.